Coming to your question, why are we doing this? Such a sea trial we're doing here is intending to show that the repeater we have developed is able to withstand the real-life conditions and challenges of the deployment and of the system, which is normally the most exposure a repeater or any wet plant really gets. We are here to put this repeater, which has been tested already through a whole range of terrestrial tests, put them to a real-life scenario of a ship being put in the water and deployed in a real-life ocean. After that, we were going to recover that repeater, because even that is also a possibility of a real system, that a repeater will get recovered and then being redeployed, for instance, or reconfigured.
When we started to work on this repeater, one of the things that we were very keen to look at was whether we could make a very small form factor repeater, but with a lot of bandwidth. Right, so to make a small form factor repeater gives us one key advantage when it comes to this type of marine activity. That is, if we can pass the repeater through the ship's plough, because this saves a lot of time and cost, both for the marine operator and therefore for our end customers. To achieve that small form factor, we've been able to sort of develop a very, very small but high bandwidth amplifier. If you start off small, it means that the eventual size of the repeater from a diametrical point of view is small as well. So we were able to sort of work with a tier 1 amplifier module maker who could bring miniaturization to the amplifier design features that we'd already established to give a 55 nanometer bandwidth amplifier, which is about 70% bigger than the competitive products today. Tomorrow we'll be showing that we can actually pass this through the ship's plough and directly bury a repeater, which will be a first.
It's also very important that you do such an operation with very, very good partners. So the partners we've worked with, we picked them very carefully. As I mentioned, we have developed a whole set of partnerships in this industry to deliver full turnkey systems. For this trial, we have gone to a tier 1 supplier of marine operations, and we've also engaged a qualification authority which will witness this trial and make sure that everything we do is in line with industry standards and exceeds them wherever possible, so that our customers have an evidence and a record that this trial is representative whatever a system would experience in a real-life situation.
We started the qualification process about a year and a half ago, because there's many features to the qualification, both from an electrical point of view and an optical point of view and a mechanical point of view. And from a mechanical perspective, when it comes to testing the repeater in a representative way to behave at sea, we tend to do most of the testing on land, because we get what we get when we go out to sea. We know tomorrow we're going to get some fairly exciting conditions, but we probably won't be able to even then test the worst case deployment and recovery conditions that this product will undergo. So we carry out a considerable amount of testing on land in bespoke test facilities where we can fatigue the cable and we can take it close to its braking load, and then look at how that behaves optically. What our customers always look for is a genuine sea trial, because it gives them confidence that no matter what you do on land, the cable has been under the water and it's gone through all the rigours of deploying a system at sea. And ironically, that could also include some of the low tension stuff that happens before you go to sea. In other words, sometimes things can happen at low tension are more severe than at high tension, because the cable can bend and you've got discontinuities and so forth. So this is an important integral part of the qualification process. We're able to load the system, and as I said, you can get some strange events and loading. We'll deploy the system and again, and We haven't finished there because we have to offload the system at the end, and again make certain that nothing has changed optically or electrically or whatever throughout that whole process.
During the trial, we also tested all other parameters, in particular via the transmission system, as well as using the supervisory subsystem to monitor the system during the trial and make sure it did not have any changes as part of the deployment and the recovery during the whole operation. After this trial, we're in the position to offer this repeater to our customers around the world for our turnkey solutions, and that will give us a competitive edge and will our customers offer more functionality, better performance and lower cost in their submarine systems.